Okay. Uh, Hello everyone. I'm Dipanita. I'll be your TA for this course. So, uh, welcome to the live interaction session of network analysis, and this is the first interaction on my part. My colleague has earlier, like yesterday, I guess he has taken this interaction session. So basically, in this interaction session, what we will do is we will look into a few of the problems that have been rolled out earlier, and we will solve them so that will help you in like solving the problems that are there in this particular course. I guess you have to give a quiz on a particular topic every Wednesday. So this interaction session is the sole purpose of this session is to help you solve those questions. So if you have any doubt in between, or if you want to ask something, you can interrupt, like you can unmute yourself and speak up, or you can put it in the chat. So we will uh, like we'll try to address all the queries. So if you have anything prior to if you have anything to ask before we start the session, you can do so now, or you can ask anything during the session itself. Okay, then let's look into a few of the problems of uh, somebody has put a message. Let me just check. Yeah, good evening everyone. So this week you have been taught uh, the node analysis and the mesh analysis using Kirchhoff's current and voltage law. So we will look into a couple of problems on this topic itself. So first, before we start, like, what do you think is a node? Can anyone comment? Like, what in your term is a node? Could anyone maybe write it in the chat, or uh, unmute and speak up? What do you think is a node? It's just a like basic question. Don't have to like worry about whether it's right or wrong. Anyone wants to comment? Yes. Srinivasan has commented, like, it's a place where many components connect. So basically, uh, node is, in real life, it is actually a stretch of like an uninterrupted piece of wire. Imagine it like that. Like there is no circuit element connected in between. So let's look into this first. So if you see, a node is just we can consider it as a single point which is connected to which different branches come and connect, and these branches consist of a circuit element. So depending on what it is connected to and how it is connected, certain nodes have some specialized name. So let me just admit them. So guys, yeah, incoming and outgoing point connect, right? So guys, try to join in time. That way, like, this interruption won't happen. Okay, so as uh, as people have pointed out, like, it is the point at, like, basically a node in which the current comes in or current may go out. You can describe it in that way. So depending on the way it is connected and to which circuit element or which way the branches are connected, there are 2-3 specialized kind of nodes. For example, in this case, this N4, this can be denoted as the reference node. Mostly if in the question it is given this is a reference node, it means like it has been connected to the ground. So the
Ma'am,
voltage of,
sorry to disturb you.
yes,
Your slide is not visible.
it's not.
It's not visible. Only nothing is visible to me.
Sorry, I think I forgot to share
You
the
can share
screen.
it. Share it,
Yeah,
madam.
yeah, yeah. Thank you for pointing out. Is it visible now?
Yeah, it's
Yeah.
visible now. Thank
Yeah.
you.
Thank you. Thank you. So for example, as I was showing in this particular circuit, uh, this N2, it is connected to the highest number of branches. It is connected to 1, 2, and 3, three branches. So the node which is connected to the maximum number of branches are known as the principal node. Okay. Then there is another kind of specialized node which is called the reference node. This reference node is that node with respect to which rest of the node voltages are calculated. And if it in question, if it is mentioned as the reference node, that means this node is connected to the ground, that is voltage of N4 will be 0, and that will simplify your calculations. So for example, if you are to apply KCL in this particular loop, you can you can apply KCL at node N2 or N3 or N1 depending on how many unknown variables you have. But if you apply KCL at N4, the equation becomes redundant. So it is always advisable that you do not apply KCL at the reference node. Now imagine if a circuit is somewhat like this. So this is a voltage source, this is a resistance, another resistance, then there is another resistance connected in parallel, there is a current source, suppose there is another resistance. Suppose there is a circuit like that. Now imagine this particular point. So there is no circuit element connected between these 2 points, right? So instead of assuming this these two are different nodes, since no circuit element is connected, this entire 4 points are treated as a single node, and these are known as supernode. Because anyway, since none of the circuit elements are present between these nodes, you can at most make one equation out of if you apply KCL in this node. So this kind of node is known as supernode. Now you will also come across nodes that have a suppose voltage source connected in between. Suppose this is node 1, this is node 2, there is a voltage source connected in between. So these kind of nodes are known as the floating node. So as as we solve the problems, you will come across this type of nodes, and we'll look into it. Now in order to solve the two major questions that we have this week, there is another thing you need to know is whether how much power is either consumed or delivered by a source. For example, there is a voltage source V as shown here, and there is I current that is flowing out of the positive terminal. So the power that is delivered is VI. Now, since the quantities, some of these quantities while calculation will be unknown, and you will be assuming the direction as per your convenience. So when you calculate that, if the current I you have assumed in this direction, that is flowing out of the positive terminal, and this I current is coming to be positive, this voltage is positive, that means the voltage source is actually delivering power. So there is this is the easiest way to remember, often in the question it will come calculate whether the voltage source delivers or absorbs power. So whenever current is living through the positive terminal of a voltage source, and so basically if you connect this into a loop, current is actually entering into the negative terminal, I mean coming out of the positive terminal, right? So it is like it appears so. So in this case it is delivering power, and if the case is reverse, it means it is absorbing power. Also in case of current source, suppose uh, you have a current source like this, suppose I 2 amps, and there is a positive voltage connected like this, then this current source is actually delivering power. But if the voltage is suppose negative, that means the voltage is like this. So this is a negative voltage and the current is coming out of the negative terminal. In that case, this current source will be absorbing power. So I hope this is clear to everyone. If it is, then we will move to our first problem. Okay. So This is one of the question that has been rolled in the previous year, where you have been given a certain uh, a certain circuit which is connected as shown here. So the three major nodes that are V1, V2 and V3 are highlighted here, and this reference node is mentioned here. So in this case here reference node has a 0 volt, right? What you are asked is you have to find V1, V2 and V3 using nodal analysis. So as you can see, this V2, V3, a 5 volt is connected across it, right? So it is kind of an example of a floating node. So just hold on. Yeah. So you can form equations at this particular node, and solve the unknowns in order to get it, right? So let us would you like to try it out first for some time, or should I go ahead and start writing the start solving together? You can put it in the chat, like what exactly should we do. Yes, Aditya, I am recording the session, so don't worry about it. I'll be uploading it in YouTube, and you can also view the recording later. But make sure if you have any doubt, you ask me right away so that it will be easier. Okay, then maybe since this is the first question, we will start together. Then, let's write the basic equations first. So, for example, let's start with, so let's say this is node 1, this is node 2, this is node 3, this is the reference node, so not required. So, in this case, there could, like V2 and V3, a voltage source is connected in between, right? So we can write like, so if we move the voltage across this two node will be V23, which is minus 5 volt, since negative terminal is connected here. So what does that mean?
It makes a super node. Okay, ma'am.
Yeah. So basically V2 minus V3 is equal to 5 volt in this branch, right? Now we will start applying KCL at the different nodes. So for example, let's start with node 1. So at node 1, so in case of KCL, which means Kirchhoff's current law, if there are suppose multiple branches and at each branch there is a current I flowing, I1, I2, I3 and I4. So summation of all this current should be 0. So summation means it also you have to look into the direction of the current. So in this case, for this node 1, what will be the equation? So suppose this 7 ampere current is coming out, this 4 ampere current is going in. If we assume a current I1 like this, I2 like this, summation of all this current should be 0. So instead of writing in terms of current, we can write it in terms like I1 will be equal to V1 minus V3 by the resistance 4 ohm, right? So at node 1, if you are to write like this, I1 is going out, whoever has unmuted, if you want to ask something, you can ask. Otherwise, you can mute yourself. So I1, I2, I3, I1, I2 and 7 ampere current are going out. The 4 ampere current is coming in. So this will equate to 0, right? So I1 is V1 minus V3 by 4. I2 will be V1 minus V2 by 3. And 7 minus 4 is 3 is equal to 0, right? So the first equation that you will have is 3V1 minus 3V3 plus 4V1 minus 4V2 plus 12 into 3, 36 equal to 0. So it is 7V1 minus 4V2 minus 3V3 equal to minus 36. This is your first equation. Sorry, this is your first equation. This is your second equation. Now, at node 3, if you similarly apply KCL, what will it be? This I1 ampere current, it is coming through the node. So it is basically entering the node. So let us assume another current I4, or let's say I dash current is coming through it, whatever is it. This is I have used I1, I2, then let this be I3. So again applying KCL at node 3, it will be, so I1 is coming in, so V1 by V3 by 4, right? V3 by 4. Now I dash is also coming in, so plus I dash. I3 is going out, so it is minus V3. Since reference node is 0, so minus 0 by 2, and 2 ampere is going in, so plus 2 equal to 0. So basically the third equation, since we only want to calculate V1, V2 and V3, we'll try to get rid of this I dash. Since there is no circuit element connected to it, we cannot, so this is the main purpose why I talked about the floating node. So since there is no resistive element connected in between, we cannot directly put an equation with respect to voltage and resistance. So we write in terms of current only. So we have to get rid of this I1. So we can get rid of this I1 by equating it to the equation by applying KCL at node 2, right? So let us separate I1 and write the rest of the equation. So I1 dash will be equal to, so if we take it this side, so V3 by 2 minus 2 minus V1 minus V3 by 4. So let this for now be the third equation. I'll just make another slide. Let's take in the equations also. So this is our V2 minus V3 equal to minus 3, minus 5, sorry. Okay, we have now applying KCL at node 2. It is So we had assumed the current to be like this, right? This is I2, this is I dash. I is given already in the question. So there are 4 branches. So basically KCL at node 2 will be V1 minus V2 by 3, 7 ampere current is also going in, so it is 7 minus I dash because that is coming out, and I, in place of I we can write, since reference node voltage is 0, so it is minus V2 by 5, which is equal to 0. So now we can replace this I dash from equation 3, right? So we have one equation is V1 minus V2 by 3 minus V2 by 5 plus 7, and we have taken I dash this side, and we substitute this equation 3 from here, which is V3 by 2 minus 2 minus V1 minus V3 by 4. So now since we got rid of this, so we have 3 equations in terms of V2, V3 and V1. These 3 equations will solve and we can get V1, V2 and V3, right? So let us simplify this. So okay, so it will be V3 will be equal to V2 plus 5, right? So let us get rid of V3 from this equation. And if we simplify this right hand side, so it's 5V1 minus 5V2 minus 3V2 by 15. So 7 and 2 I brought it this side, so it is 9 is equal to, so in place of V3 we are replacing with V2 plus 5. So it is V2 plus 5 by 2 minus V1 minus V2 minus 5 by 4. So would you want me to solve this equation, or will you be able to go ahead on your own beyond this point? So you replace V3 in this particular equation also. So it is like 7V1 minus 4V2 minus 3V2 minus 15 equal to minus 36, right? So this equation will be in terms of V1 and V2. So it is 7V1 minus 7V2. If you take 15 that side, it is minus 20, 21. So cancelling out 7 from both the side, it will be V1 minus V2 equal to minus 3. So this is one of the equation in terms of V1 and V2. This is another equation in terms of V1 and V2. Do you want me to simplify it?
No, ma'am, go ahead.
Okay. So if you could you solve it and let me know, like what is V1, V2 and V3? Did anyone get? You guys are solving it, right?
Yes, ma'am.
Okay. So what is V1? If anyone got it, please let me know.
2 volt, ma'am. 2 volt.
Sorry?
2 volt.
2 volt, yeah. V1 is 2 volt, V2 is?
5 volt.
Right. And V3?
10 volt.
Okay. So since we have now V1 and V2 and V3, the rest of the three questions you can find out. So V2, V2 is 5, V1 is 2, this is 5, this is 2, and this is 10. So we can easily find the current. I is equal to V2 by 5. So 5 by 5, 1 ampere, right? Then the question is find the electrical power delivered, supplied or generated in form of power converted to electrical power by the 4 ampere current source. So we have to find the power that is either delivered or supplied by this 4 ampere current source. For that, what do we need? We need the voltage across this, right? We need this voltage to find the power. Is it fine?
8 watts.
Sorry?
8 watts.
Oh, you're saying the answer? Yes, it is 8 watts. So power is equal to V into I. So I is given as 4 ampere. What will be the voltage? So the voltage across this will be minus of V1, right? Or you can consider, since there is a positive voltage connected across it, so V1 is 2 volt, right? And the current source is connected in this way, that means the current is coming out of the positive terminal, so this is basically supplying the power. So 4 into 2 volt, 8 watts. In case of, then the other question is the 2 ampere current source. For this, it will be the voltage across
20
this
watt.
is, yes, it is V3 voltage connected across it. So 10 into 2, 20 watts. So if everybody is done with this question, can you move to the next one? Okay, so you have anything else to ask? Okay, then let's move to the next question. So this has been rolled out previously too. Like this is the second question that was rolled out last time. So in this case, you have been given a circuit and you have been asked to use mesh analysis in order to solve in order to solve V1, V2 and few other power related questions. So can you proceed with the problem? For that, what you have to assume in case of mesh analysis? In mesh analysis, you have to assume current in each of the mesh, right? So
Yes. Yes,
Yes.
ma'am.
yeah. So let this be like one current I1, this be I2, I3 and I4. So I2, so if we just simply look at the circuit, what will be the value of I1?
2 amps.
Yes, because
2 ampere.
no other current is flowing through this branch and this I1 current is flowing through this entire loop. So I1 is equal to 2 ampere. Now if we look at this particular branch, so I3 current is flowing downwards and I4 current is flowing upwards. So, and there is a net current of 3 ampere. So I3 minus I4 will be equal to 3 ampere, right?
Yeah.
We have these two equations. Then we have to apply mesh analysis in this circuit. So the first mesh analysis, suppose let's name the mesh 2. This is mesh 1, this is 3, and this is 4. So first mesh analysis we do in loop 2, right? So it means like the voltage, we will calculate the voltage across each of these resistance and equate it to 0, right? So if we move in this direction towards the direction of current, which is I2, so it will be minus of 5 I2 minus, so I2 current is flowing in from left to right, and I4 current is flowing from, sorry, I2 current is moving from right to left, and I4 current is moving from left to right. So it is I1 minus I4. Then if we look into this 20 ohm resistance, it will be again 20 I2 minus I1, because I1 is flowing in the opposite direction.
Ma'am, how I1 minus I4? I2
Sorry,
is flowing. Ma'am, how I1 minus I4?
I1 minus I4. Okay, in this 5 ohm resistance,
I2 minus I4 minus 5 ohm.
yes.
I2 minus I4, no.
So I2 current is flowing across this direction, right? I4 current is flowing across this direction. We are moving, like you can move clockwise or anti-clockwise depending on it, right? So what you are suggesting, if we write I4 minus I1, then this minus sign won't be there. It will be 5 I4 minus I1, right?
They are telling about second term which you written minus 20 into I2 minus I1. They are telling. First
Okay,
term is okay. Whatever you written is correct.
okay.
Second term they are telling I2 minus I1 you written. What they are asking is how it is I2 minus I1.
So I2 and I1 current is flowing this way. This is 20. So we are moving in the direction of the current. Like we are moving in the loop, in this particular loop, we are moving this, like either clockwise or anti-clockwise. You have to choose whether you take it as positive or negative. So for this case, like there is no difference, right? Like look at the 5 ohm resistance. Since you were moving along this direction, you have taken a negative sign and put I2 minus I4, right?
Yes,
This
ma'am.
is
That's my
I2.
doubt. That's my doubt. I2 minus I4.
Correct, correct,
Yes,
Yes,
ma'am.
ma'am,
yes,
yes.
yes, yes. Okay, the second one, like I thought, sorry. Yeah, now it is fine.
Yes,
Minus
ma'am.
Yes, ma'am.
5.
Okay, 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 madam.
Sorry. Okay.
Yes, ma'am,
Correct,
it's
correct,
fine.
correct, ma'am,
So
correct, ma'am.
yeah. So it is then 10 I2. This is the first equation. So I1 we can like put in here and simplify it. So let's, like this is 5 I2 plus 5 I4 minus 20 I4 minus minus, this will be plus 20 I1. I1 is 2, so it is 40 minus 10 I2 is equal to 0. So 5 uh, so 5 minus 20 I4. So there is, I think I made a mistake here, right? It is 20 I2. So there are 3 I2 terms. So total is 35 I2 plus 5 I4 plus 40 equal to 0. So you divide the entire equation by 5 and take these two I terms on the right hand side, so it will be 7i2 minus i4 equal to 8. This is your first equation. For the second equation, we will apply across mesh 3 and mesh 4. So let me just take a different color. So the next loop we will apply into this bigger loop, right? So applying it at 3 and 4, what we have is similarly like the previous one, we will do this. So it is minus 20 I3, then we are moving this way, so 10 volt, we come across 10 volts, so plus 10 volt.
Ma'am, where is coming from plus 40?
Plus 40. So in
Yeah.
place of I2 we are putting the value 2, because it is given I2 is equal to 2 ampere. We have calculated this, right? I2 current is flowing here, sorry, I1 current is flowing here. So this same current is this 2 ampere source that is shown here. So it is the same, basically the same current. So I1 is equal to 2 ampere. In place of that, here in I1 we have equated it to 2 ampere. We have just plugged in the value of I1. So this 20, if we multiply 20 into 2, right? Are you getting it?
Yeah. Thank you.
Yeah. So 20 I3, then plus 10, then we move across this 5 ohm resistance. So minus 5, here it is I4 minus I2. Then we move across this voltage source, which is plus 20, and we complete the loop, it is equal to 0. So it is, let us simplify, it is minus 20 I3 plus 10 minus I4 plus 5 I2 plus 20. So if you just take it to the other side, and it is 20 I3 5 I2 5 I4 equal to 30. So divided everything by 5, I2 plus 4 I3 plus I4 is equal to 6. This is your third equation. So you have three unknowns now, I2, I3, I4, and you have three equations and three unknowns. So you can solve this three, right? So I3 minus I4 value is given, and you have another equation in I2 and I4, and this is the third equation. If you solve 1, 2 and 3, you'll be able to get the currents, right? So will you go ahead and solve this? And let me know what is I1, I2 and I3. Sorry, we have I1. So what you need is I2, I3 and I4. Could you tell me what are your answers?
I4 is equal to minus 1.
Okay. I2 and 3.
I3 is equal to 2.
I3 is equal to 2. Did you calculate I2?
Yeah, 1.
1, ma'am. 1.
Okay. So now that we have all the currents, we can calculate V1. So what will be V1? V1 is actually the voltage across this 20 ohm resistor. So V1 is equal to 20 into, so I1 current is going down, and so it is I1 minus I2. So 20 into I1 is, we have known, it is known, so it is 2 minus I2 is 1. So it is 20 volt. So this one is equal to 20 volt. What is V2?
Minus 10.
Okay. I4, I2. So 5, I4 is minus 1, I2 is minus 1. Yes, it is minus 10 volt. So the third question of this part is, find the electrical power delivered or generated and other forms of power converted to electrical energy by the 2 ampere current source. So you have to calculate the power generated by this 2 ampere current source. So for that, what do you need? Suppose this is node A, this is node B. Let's name the nodes C, D, and E. So maybe,
Please change the color of pen, ma'am.
yeah, I'll write it in fresh. So A, B, okay. So we need to find the power that is dissipated by this current ampere source, right? So for that, what we need is the voltage across it. That is, we need VAB. So how can we get VAB? It is VAE. So just for right now, if we just assume like the voltage is like this, so it should be VBA, right? I'll rub this one into it. For now, we are assuming that the positive side is this side, and like let's see how it comes up. So VBA is actually a summation of the voltage that is here and the voltage that is here. So it is actually equal to VBE plus VAEA, right? So we already have V1. V1 is equal to 20 volt. And VEA. So VAE is equal to minus 10 volt. So the reverse VEA is equal to plus 10 volt. So this is equal to 30. So the power that is delivered by the 2 ampere current source is equal to 2 into 30, 60 watt. Now you see the voltage that we got is actually positive. So the current is coming out of the positive terminal. So this is delivering power, right? Similarly, for question number 10, it is asked to calculate the
VEA
power.
will be minus 10.
Sorry?
VEA will be minus 10.
No, see, the negative side of the terminal is connected to A side, right? So VAE is equal to VA minus VE, right? So this is negative. So this is minus 10. Because the negative side of the terminal is connected to A and positive is connected to E. So E is at a higher potential than A, right? So in this case, it is the reverse. So VEA is equal to VE minus VA. That is minus of VA minus VE. And this we know is 10. So minus of
Okay.
minus 10 equal to 10.
Yeah,
Right?
okay.
Yeah. Now the voltage across 3 ampere current source. So it is basically this voltage V. So let us assume since it is in the question, it is given it is delivering the power. So this, let us assume this to be positive, this is negative, right? So the voltage across the 3 ampere current source will be VDE. Now VDE means it is VDC and VEC, right? Sorry, let me take the eraser. So what will be VDE? Could you
VD VD plus VC
V?
D plus VC.
No. This voltage will be equal to summation of these two voltages, right?
Huh.
So it is voltage.
VDC
Yes.
plus VC.
Yes.
Plus VEC.
EC. It is EC.
No. C only.
DC CE.
C. Huh.
Yes. So DC is 20, right? And we got V2 to be equal to minus 10 volt. So what is V2 in terms of E and C? Could you tell?
V is
EC, right? So if we are to write CE, it will be negative of negative 10. So it will be positive 10, right? 30. So the power generated will be 3 into 30, 90 watts. Is this okay?
Yes, ma'am.
Yes. Now find the power dissipated by the 10 ohm resistance. So if there is a resistor, it will always dissipate power no matter what. So where is the 10 ohm? Okay. So across this particular resistor, you have to find out.
10 watts.
Yes, because the current of we have assumed this to be I2, right? I2 is 1 ampere. So 1 ampere current is flowing. So the power across 10 ohm resistance is 10 watts. And the final one is find the total electrical power delivered, supplied or generated by the two voltage sources together. So we have to find the power either delivered by this particular voltage source and this particular voltage source. So let me use a different pen. So how are you going to calculate it? V into I, right? The power. So the power that is delivered or generated by the 10 voltage source, it is V into I. So voltage is 10 volt. What is the current? So in this case, I1 is flowing like this, and we have assumed I3 to be flowing like this. Now I3 is 2 ampere, I1 itself is also 2 ampere. So basically it is I3 minus I1, I3 minus I1, right? So it is 10, 2 minus 2, 0 watt. So it is neither delivering nor supplying. What about the 20 volt source? So here only I4 current is flowing, right? What is I4? I4 is equal to minus 1. So imagine this voltage source. So positive terminal, negative terminal. So I4 is flowing this way and it is minus 1. So actually in reality I is flowing this way, right? A current of 1 ampere is flowing in this direction in reality. That means it is entering through the I4. Yes. Okay. So the power will be 20 into I4.
Minus 20 watt.
Yes. Minus 20 watts. Usually when the power is negative, it means it is delivering power, right? But we have assumed like if we simply put I4 this way, it is we are getting it as minus 1. Are you getting my point?
Yeah.
Okay. If anyone has any doubt, you ask, otherwise we'll move to the next question.
Ma'am, where can I get the recording of this session?
So it will be uploaded in the NPTEL. The link will be given in the NPTEL site. You can view it from there. So both the recording, like yesterday my colleague had done the interaction session. So you'll get both the recordings in NPTEL site. There is a like a regular update that is given, right? Like suppose the link where the link of this interaction session is also uploaded.
Yes, ma'am.
So
Link uploaded, but not the recorded.
so
It's only
in
live.
in like in the uh, either in the discussion where they upload like they give the link, there the live interaction session link will be like the recording link will be given, or it will be given on the side, like where you have the week 1, week 2, week 3 lectures, right? Up to week 3 it is uploaded. So at the
Okay,
end
okay.
there will be interaction session lectures.
Okay, ma'am.
Okay. If you don't have anything to ask then anymore, so we'll move to the next question.
Madam,
Wait, ma'am.
madam, how we selected that it mass current will be allowed will be applied not nodal? How we will come to know, madam?
So in general, in any question, it will not be, it will like in the final exam, this is just showing you the different methods, right? It may not be mentioned like you have to either use nodal or mesh analysis. It all depends on your practice. Like if you see a circuit, for example, in this case, this particular circuit, if you see, it kind of has like it kind of looks like it has many loops, right? If you apply nodal analysis in this case, like there will be this one node, one equation missing, like which we have seen in the previous question. So mostly when there are multiple number of branches that are connected in this way, we try to use nodal analysis, because in nodal analysis we assume branch current and solve it. But when there are a lot of easy loops that are visible in the uh, circuit, you tend to go with mesh analysis. Then again, this problem itself can again be solved using nodal analysis, not necessarily that you will have to use mesh analysis. So it all depends on your practice, which you are more comfortable with, and how the circuit is given. Do you get it?
Thank you, madam.
Yeah,
Thank you, madam.
yeah. So let's look into another problem. So here a circuit is given and you have to find I1 and I2. So just as we were asking about whether to use mesh or nodal analysis, with your intuition, what do you think we should go for? Could you could you comment? What do you think you want to apply here?
Nodal, madam.
Yes, because you see the number of mesh here are actually 1, 2, and there are a lot of actually branch currents that are mentioned here. So the better option would be to apply nodal analysis, and anyway you have to calculate the current. So in nodal analysis you will be able to get the branch current by knowing the voltages across these two branches. So and can you I'll just name 1, 2. Could you identify the wait, just hold on. So could you identify the supernode here? So let's say this is 1, this is 2, 3, 4, 5, 6, 7. So which is the supernode here? I'm audible, right?
Seventh node.
Sorry?
Seventh node is super.
No. Actually, the thing is, this seventh node is the reference node. It is, although it appears like, that is what I told, like this specialized nodes, you have to be you have to observe. So look into this circuit, like all the node voltages can be calculated by taking this as the reference. So this is actually the reference node, which is assumed to be V equal to 0. In this case, this super node is 3 and 4. You see, no element is connected between this. So supernode is actually that node in which only one equation will be formed. See, even if you apply KCL at 3 and 4, irrespective of that, you will get two redundant equations and you will only get one equation out of these two nodes. Maybe with more number of problems, this will become more apparent.
And then 1 and 2 also will be super.
I mean, no, since no element is connected into it, it definitely can be. Right?
Okay.
Okay, then let's remove these notations and let's start solving this. So this node, let's put it as so we'll start from here. This is node 1, this is node 2, and as you said, this is a super node, so this will be node 3, right? So we will get three equations out of this because there are three nodes, and this is the reference node. Okay, so first let's apply at 1. So applying KCL at 1. So this 25 amp current is going here, I1 current is mentioned here. Let us just assume this to be. So instead of assuming current, let's give voltage. So this is V1, this is V2, and this is V3. So now this node is actually here connected to this 20 volt, right? So directly we have V3 equal to 20 volt because the positive terminal of this battery is connected to this particular node, right? Is it okay?
Yes, ma'am.
Yeah. So now applying KCL at 1, we have, let us assume one current that is flowing downwards. So we have,
Now V1 will also be 25. Okay, sir.
sorry?
Nothing. Sorry.
Okay. So when we are applying KCL at 1, it is, So this 25 ampere current is going into the node. So let us assume it to be all the current that are going in to be positive. So this I dash current is coming out, so it is negative V1 by 4. Then V1 minus V2. V2 is the node voltage of this supernode. So it is going out, so we assume it to be negative. So V1 minus V2 by 10 is equal to 0, since only 3 branches are connected in one. Right? So let's simplify this. V1 by 4 plus V1 minus V2 by 10 equal to 25. So the LCM will be 20 by V1 plus 2V1 minus 2V2 is equal to 25 into 20. So 7V1 minus 2V2 is equal to 500. This is your first equation. Now apply KCL at node 2. So KCL at 2, if we apply, so this I2 ampere is coming out. So let us again assume that those current that are, so let this be I double dash. So in this case I2 is going out, so let us assume it is negative. So negative of V2 minus V3 by 1 ampere, no sorry 1 ohm, and this is going out. Then I double dash is also going out, so minus V2 by 2, and 20 amps is going in. I1 current is also going in, so it is V1 minus V2 by 10 equal to 0. This is your second equation. So now we have V3 is equal to 20 volt. So if we simply just put this, so we'll take rest of the equation on that side and 20 on one side. So it will be V2 minus V3 plus V2 by 2. If I take this part on that side, it will be V2 minus V1 by 10, right? Equal to 20. Now we have V3 is equal to, this is equal to 20 volt. So if we take it on the other side, this will become equal to 40. And we take the LCM of rest of it. So 10 will be the LCM. So 10 V2 plus 5 V2 plus V2 minus V1. And it will be equal to 10. So 15, 16. 16 V2 minus V1 is equal to 400. This is your second equation. So you have two equations and two unknown. You can easily calculate the value of V1 and V2, right? So this is pretty like straightforward. So maybe you multiply equation 2 by 8. So 56 V1 minus 16 V2 is equal to 4000. So if you add 3 and equation 2 and 3, this 16 V2 will get cancelled out. So 56 V1 minus V1 will be equal to, so it is 4400. V1 is equal to 4400 by 55. So let us just calculate 4400 divided by 55.
80.
Yes. So this is equal to 80 volt.
V2 is 30.
Yes. So V2 will be equal to 30 volt. Now that you have V1, V2 and V3, you can calculate I1 and I2, right? What will be I1? I1 will be equal to V1 minus V2 by 10. V1 is 80, V2 is 30. 30 by 10. That is 5 ampere. So what will be I2? I2 is, what will be I2?
Ten amps.
Yes. So I2 is V2 minus V3 by 1. 30 minus 20 by 1 is equal to 10 ampere. So this is typically one of the question using nodal analysis. I hope everyone has done it. If yes, then we'll move to the next question. Shall we move to the next one?
Yeah, ma'am.
Okay. So this is another question where so you have been given a certain circuit which is shown here, in which one end of it is connected to 24 volt, this other end is minus 12 volt. This is not like a typical circuit that you usually see, a closed one. Now this particular node is connected to the ground, and what you have to calculate is this unknown parameter R in with the information that is given. So could you try and just attempt it on your own? Then we will start solving it. So what exactly are you going to use here? Nodal or mesh
Mesh
analysis?
analysis. Mesh.
Uh, just try it out on your own. I'll give you a couple of minutes to try it. If you're done, you let me know. If you have any query, you can also ask. Then we'll solve this. Okay.
Is it 1.1 mega?
Sorry?
1 mega ohm?
No. What have you used?
Node.
Nodal analysis, right? This problem will be better using nodal analysis actually. You have got it to be 1 mega ohm.
Yes.
No, like you're slightly off by your order.
It's 10 megaohms.
Sorry?
10 megaohms.
10 mega ohms? Anyone else got it? So you have this one node here, right? Assume a voltage V at this node.
Is it 100 kilo ohm?
Yes, that is the correct answer. Okay, maybe I'll give it a minute and then we'll start with the solution.
Ma'am, when we'll be starting your problems on inductors and capacitors?
So that we will solve in the next session, right?
Thank you.
Yeah. This week both the interaction session will be based mostly on like nodal and mesh analysis, because I probably like tomorrow there is your assignment on this. Okay, then let's look into the solution. So let us assume a voltage V at this node. So let us assume that all the currents are going out of the node. So basically I1 plus I2 plus 10 microampere that is given is equal to 0. So if we like replace it in terms of voltage, since voltage at the end of this branch is given, so I1 is equal to V minus 24 by 1 mega ohm, that is 10 to the power 6. This is actually given in micro ohm, so this is 10 to the power minus 6, right? So I2 is V minus of minus 12, right? Because this is given as 12 volt by 10 to the power 6 plus 10 to the power minus 5 is equal to 0. So if we get rid of this 10 to the power 6 and move it towards that side, so V minus 24 plus V plus 12 is equal to 10 to the power 6 into minus 10 to the power minus 5. So this side it is 2V minus 12 is equal to minus, so 10, only one 10 will be remaining. So 2 volt is equal to let me just check it out. So it is, if I take this 12 on that side, it will be 2, 12 minus 10. So V is equal to 1 volt. Now we have the current in this branch and we have the voltage. Since this is reference, so the voltage in here is 0. So basically the current that is 10 microampere that is flowing is equal to V by R in. So V by R in, right? So R in is equal to V is 1 volt and this is 10 into 10 to the power minus 6. So this is 0.1 into 10 to the power 6 or 100 into 10 cube. So 100 kilo ohm since it is 10 cube. Everyone got this one? If yes, then we'll move to the next question. Anyone has any doubt?
No, ma'am.
Okay. So for this question, it is given you have to determine the power that is associated with the 3 ampere current source. So for that, what analysis will you use?
Mesh analysis.
Mesh, madam.
Yes, definitely mesh, because you can see 3 different loops. You can easily apply mesh analysis. So could you start with the problem? So let us assume there is a current I1 flowing to the first loop, I2 flowing through the second loop, and I3 through the third loop. So write down the equations of these 3 loops and solve them in order to get the current in this loop, from which we can get the voltage and from which we can calculate the power, right? So start doing this on your own first. Is there any current we can easily identify its value from this?
I1, ma'am.
I1,
Yes,
3 amps.
yes. I1 is equal to 3 ampere because this same current is flowing here also. Now for us the unknown will be I2 and I3. So where are you applying the mesh, the first mesh?
I2, ma'am.
Yes. Since we already got I1, we will apply first the mesh equation here and here. So in loop 2, so if we move along the anti-clockwise direction, it is 3 minus 2 into I2 minus I1 Then through the 3 ohm resistor it will be minus 3 into I2 minus I3. Through the 1 ohm resistors minus I2 is equal to 0. So we have I1 is equal to 3 ampere. So this will be equal to plus 6 minus 3 I2 minus 0, right? 3 plus 6 is 9 minus, we have 3 I3, so sorry, I2 minus 6 I2 plus 3 I3 is equal to 0. Since all these are multiple of 3, we can further simplify 3 minus 2 I2 plus I3 is equal to 0. So let us write one of the equation in terms of I2 only. I3 is equal to 2 I2 minus 3. So this is your first equation. Then you will apply KVL across this third loop. So if we move along the anticlockwise direction, first it will be minus 2 into I3 minus I1 minus 7 into I3 minus 3 into I3 minus I2. This will be the second equation. So minus 2 I3 plus I1 is 3 ampere, so 3 into 2 6 minus 7 I3 minus 3 I3 plus 3 I2 is equal to 0. So you have minus 7 minus 2 minus 9 2 6, sorry, this is I3, so 10 12 minus 12 I3 plus 3 I2 plus 6 equal to 0. These are all multiple of 3, so we can further simplify it. So it's 4I3 plus I2 plus 2 equal to 0. Right? Now we have I3, so we'll just substitute in this equation. 2I2 minus 3. So anyone got the value of I2? What is I2 coming up? Anyone got the value of I2? You're solving, right? Anyone has anything to ask?
No, ma'am.
Okay. So you have I2. Now you can calculate I3. 4 minus 3 equal to 1 ampere. So now that you have I1, I2 and I3, you can calculate what is the power delivered. You try on your own and let me know. So now you have this, right? You have the three currents. 3 ampere is flowing like this. Then I2 is 2 ampere and I3 is 1 ampere. So these are the three loop currents. So what we need to calculate the power delivered across, like by this 3 ampere current source? What do you need to find out? You need to calculate the voltage across this, right?
Yes.
Yes. So please calculate the voltage. So you have this. Hmm. 2.8. Um, Krishnasamy Subramaniam, like 2.8. I do not understand. Are you?
It's two only. Sorry, it is two only. By mistake, I typed as 2.8.
Uh,
Current
okay.
calculation 2 I
Okay,
type
okay. I
instead of
see, I see. Okay, I see. Yeah. Okay, so I hope the current calculation is done for. In assignment, like in the quiz, you'll be given like different questions, but kind of similar. Like you have to calculate the power output, or you'll have to calculate the branch voltage or node voltages basically, and the branch currents. So like that is why like I was just trying to make you practice all these questions. So anyone had calculated the power? Please try to calculate the power. Like if you have trouble how to approach, you can ask, like I'll suggest, because this is one of the last problems for circuit today.
I
So
need a hint, ma'am, to
yes.
calculate voltage across the ampere.
So okay. So you whenever you approach this kind of problem, the thing you have to either apply is KCL or KVL. Using that, you have calculated the loop current, but you know the current across a certain, like if you start at this point, if you travel through the circuit like this and come back, that total voltage summation of all the voltage should be 0, because KVL is applicable for all, right? So I'll just use a different color ink. Suppose you assume that there is a voltage V across this particular current source. So if you apply another KVL across this particular loop, now using only voltages, since we have the current, you can calculate the voltage across all the resistors and the given ones. So if you apply KVL in this loop, you will be able to calculate this unknown V, right?
Yes, ma'am.
Yeah, that is how you have to go. So in the previously rolled out assignment, like we had solved earlier, for this one, I guess. Yeah, for this one, what we did is like if we had used the same concept, like if we had assumed that like not this one, sorry, the current, yeah, this one only, this particular current one, we calculated the voltage across this current, right? VAB. That time it was pretty much straightforward because there were not many circuit elements connected through it. But like in this circuit, there are a couple of circuit elements connected. So you have to calculate the voltage. Basically, you have to find this. If we consider this A and this to be 0, you have to find VAO. So it will be voltage across this 2 ohm resistor, 2 ohm resistor, and this 3 volt.
Thirty-six delivered, ma'am. See.
Yes, 36 delivered. That's the correct one. So anyone else tried that one?
Thirty-six watt delivered.
Yes. Okay, then we'll just, since two people already got it, so let's assume there is a voltage V across this current resistor. So if we apply KVL, what will we get? So we are traveling, let's say clockwise direction. So V minus 1 into the current that is flowing, that is 3 ampere, minus 3 into, so 3 ampere current is flowing this direction and 1 ampere current is flowing this direction. So it is 3 minus 1, right? Minus 2. So 3 ampere current flowing this direction, 2 ampere current is flowing in this direction. So basically 3 minus 2. And we are entering through the positive terminal of the battery, so minus 3 is equal to 0. So V minus 3 minus 3 minus 2 minus 3 equal to 0. So V is equal to 3 plus 3 is 6, 9, 10, 11, 12. Sorry. So this is, sorry, this is 3 into 2. So this is basically, what did I do? This is 2 ohm resistance, 3 minus 1. So this is 2 into 2, 4. So 3 plus 4, 7, 8, 9, 10, 11, 12. 12 volt. So the voltage across this 3 ampere current source is 12. So the power is 12 into 3, 36. Now you see the current is actually coming out of the positive terminal of the battery, like positive terminal of the voltage, if we assume it in this way. So it is 36 watt. Everyone is clear on this one? So in general, like for the first quiz, it will be restricted to nodal and mesh analysis only. And the basic thing that we need to calculate are the branch currents, the node voltages, and the once we have those, we can go ahead with calculating the power, depending on whether it is delivering or absorbing. So I need a quick feedback since this was the first interaction. So for example, in this interaction, should I have also included the next week lectures problems? Will that be beneficial to you guys? Could you comment on that?
Yeah, ma'am.
Actually, week 2 assignment is also tomorrow.
Sorry,
Yes, ma'am. If we had
week two.
even the week
Week 2
two's
submit.
assignment deadline is tomorrow. So if we had the problem, so we could get a better clarity on how to solve those
I
questions.
see. Okay, so the week 1 assignment has already been that time is over.
No, ma'am,
No,
that is
ma'am.
also
Week one and
tomorrow.
week two both on tomorrow.
Oh, I see. And what about week 3? Is it the next week?
Yeah, ma'am, that's a
Yes,
15.
ma'am. It's on
Yeah, ma'am.
15.
15 February.
Okay. So what I'll do, like initially what we were informed is to go per week. So maybe in the next week, uh, I'll also include like the week 3 lectures, few of the problems, right? That would be
13
Yes,
good, right?
February.
ma'am. Please. Yes, ma'am.
So,
That would be very appropriate.
okay. Okay then. If you have any basic thing to ask about inductor and capacitor, you can, because I do not have it prepared. So if you wanted to ask anything about the concept or anything, I can try and help you.
Ma'am, what does steady state mean? Steady state.
Okay, so steady state means when time has approached infinity. So suppose you are so there is a suppose a battery connected across a capacitor, and suppose there is a switch here. So let me, so imagine there is a switch here. So at time t equal to 0, this is open, and at exactly like before time equal to 0, this was open all along. At time exactly t equal to 0, when we start the timer, this has been closed. So initially this capacitor probably was not charged. Now it is closed, it started to charge. Now when time will approach infinity, that is a long time have passed, what capacitor will do, it will store all the charges from this battery and store it in the parallel plate of the capacitor, right? Then when it will store, it will appear like a voltage itself is there across this particular capacitor, and it will behave like no more charging will happen, and it will behave as a open circuit. So this point of time when a long time has passed, this is known as the steady state. So inductor
So
and
inductor will act like a short circuit
exactly. So initially,
at
when
steady state.
at steady state, it will appear as if uh, there is no like nothing to restrict it. It will appear as a short circuit. So the problems when you will solve for this, what you have to look into is whether it is at time equal to 0 or steady state, that is time equal to infinity. Also note that there in the question it might be possible, like sometimes they ask a bit in a tricky way, like let's say uh, at time t equal to minus suppose minus x, whatever the time be, this switch has been closed. So at time t equal to 0, it has achieved steady state. So at that particular time, even at t equal to 0, you will have to assume the capacitor is open circuit and the inductor is short circuit and all those. Did you get it? It depends on when the steady state is achieved. So don't keep in mind, like it's not just at time equal to t equal to infinity this is happening. It might so happen that depending on the circuit switching condition when you closed or opened, depending on that your steady state will achieve. And also note that current across an inductor cannot change simultaneously. Suppose a current I was flowing across this inductor, okay, and it was connected to some current source, let's say, and suddenly this switch is opened. Now the inductor is like this. So at this t equal to 0 is at that instant this switch has been opened. So at t equal to 0 minus and t equal to 0 plus, that is just before switching and just after switching, the current through this inductor will always remain constant because current cannot instantaneously change across an inductor. Similarly, in case of capacitor, voltage cannot instantaneously change across the capacitor. So whenever you have to solve in most of these circuit problems, you will see that you will have to use these two approaches. Like current cannot simultaneously change across an inductor, and hence you will write the equation like it may be volt like you can use KVL for or KCL depending on whether it is inductor or capacitor, and which is useful, which will help you solve faster. So this steady state condition and instantaneous switching, these two conditions you have to remember.
Yes,
It,
ma'am.
yeah.
That is we call it a transient state.
Ma'am, sup
Transient analysis is like when after the switching has occurred, like just a little bit after switching. Suppose you had switched at t equal to 0 and t equal to infinity is the steady state. So between that, let's say t equal to 2 second, this is the transient analysis. What happens is during this time actually the sinusoidal has not, like it has not reached a steady state condition. So the in case of graph V versus I, you will see like it is fading slowly, right? So, and here, this is where the steady state has achieved. This is not a very smooth curve. It might so happen that there might be some oscillations. So this portion is known as the transient analysis. This will depend on the magnitude of your inductor and capacitor, and there will be a time constant t equal to I think RC. For capacitor it is RC, and for inductor it is R by L, I think. Just look into the formulas. So
Yeah,
transient
okay.
analysis involves when it has not reached the steady state, it has not become a constant saturated value. There is little bit of oscillations in the system itself.
Ma'am, suppose if the question says the switch was closed at time equals infinity. So how are we supposed to approach that time, ma'am? So suppose they might ask us to find the current in the branch, and when the switch is closed, time equals to infinity. So we consider it as an open circuit and say current is zero, or how do we approach those kind of problems?
So it depends on at time t equal to 0, what was the state of your circuit. Suppose, let's say you're given, let me take a fresh page. So, okay, suppose this is a capacitor, okay, and there is a switch like this parallel to it. This is a voltage source, okay. So initially, if this is open, that means the capacitor itself is charging, right? Because the current has nowhere else to go, it is charging. So at t equal to infinity, when this switch is closed, the voltage across the capacitor, it suddenly, this is actually a sudden short circuit, right? So the voltage across this capacitor cannot instantaneously go to zero, although there is a short circuit in parallel to it. So even if it is said like at t equal to infinity, the switch is closed, that means just before closing it, this has, and it will be mentioned in the question, like it has been on for a long time or something like that. Long time means it had reached steady state, and then suddenly it was closed. If it is not mentioned in the question, when it was like if this before the switching, how long the system was there, usually it is not like written like that. In the question it is mentioned like what was the condition of the system for a long time. Even if at t equal to infinity this switch is closed, if this was open and kept like this for a very long time, this would have reached the steady state. For transient analysis, they will mention t equal to some value like 2, 4, 6, x, whatever the value that they will mention, like find out the equation of the current across this or voltage across that uh, at time t equal to this much, if the switch was open or closed up to a certain point, like at t equal up to t equal to 0 it was closed or open or whatever. Like, did you get the gist of the approach?
Yes, ma'am. Thank you.
Yeah. If I had known like your deadline was tomorrow, I would have gotten a pretty, like, we were asked to solve the previously rolled out questions. So,
So we were expecting to see week two's problems, ma'am. So
okay, I see.
especially when it involves normal circuits that we do which includes capacitors and
Capacitor and
inductors.
inductors.
So we have no idea to how, yeah. So we have no idea how to solve those. In the sense, like, we have an idea, but we just want to make sure that whatever we have learned, it's the right way.
Okay, okay, I see. Okay, then, so for the next week, what I'll do is I'll include maybe one or two questions from the capacitor or inductor, which will clear out, like, if you have any doubts, and the question from the third week, whichever the topic it will be.
Yeah, ma'am.
Yes, ma'am. Differential equations.
Okay, okay, okay. Then, do you have anything else to ask, or we can wrap this one up for today? Anyone has anything to ask? Be it like the basic concept or something else, something from the assignment you did not understand. Anything is fine. Everyone has attempted the first week's assignment. Like, have you completed or will you do it tomorrow?
Yes, ma'am. I have done it.
Okay. Um, so
For me. Thank you,
yeah.
ma'am.
Okay, then, like, if none of you have anything else to ask, I'll stop presenting and we'll get this done for today.
Thank you, ma'am.
Thank you for attending.
Thank you, ma'am.
Thank you, ma'am.
Yes, ma'am. Sure.
Madam,
Yes.
madam, I read from one sir. He told if voltage was connected within two nodes, that is called a super node.
Uh, Actually, supernode is the bigger classification of when there is no circuit element connected across two node.
No, madam. Similar,
Even we
whatever
were taught
connected.
in a similar way, ma'am.
Sorry?
Even we were
Wha-
taught when we were taught it was as a super node, not as a floating node. So is
So,
it referred as floating node or super node when there is a voltage source between two common nodes?
um, that as per I know, like supernode is the broader classification when there are no like no resistive or conductive or inductive element connected between these two nodes. Okay, so this floating node is a specialized version of supernode. Like it's a classification like we put on. Like everything is called as a node, right? That is the broader classification. The smaller classification are reference node, supernode, and all those things, right?
Okay. Thank you, ma'am.